Hello everyone. In this video, we're going to be evaluating an infinite sum. An infinite sum with factorials. So we have 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial. Even though those terms were not written, there is a pattern. The numerators are consecutive positive integers and the denominators are factorials, but they're just one more than the numerators. Okay? Hopefully you get the idea. And these kinds of problems, you've probably seen them before with finite versions, but I don't think there's been an infinite version of this problem, so that's why I wanted to kind of do a different version here. Before we get into the infinite realm, though, we're going to take a look at some of the finite stuff. So what happens if I just add a couple terms? For example, with the first term by itself, 1 over 2 factorial is going to give us 1 over 2. A lot of times if you're trying to evaluate a series, like trying to find a sum, then you may want to look at some partial sums because they might give you an idea what the pattern might look like. And then you can make a conjecture, say that, okay, this sum looks like this, and then you can test it out, obviously. And then, of course, the convergence will also come into play. We'll talk about that too. And then at the end, I'm going to show you some results from Wolfram Alpha. Anyways, so let's go ahead and take a look at more terms, like what happens if I add the first two terms, kind of like another partial sum. This would be 1 over 2 plus 2 over 6, because 3 factorial is 3 times 2 times 1. And that will be like the same as 1/2 plus 1/3, and that will be 5 over 6. Does that ring a bell? Maybe not yet. Okay, let's do a little bit more and then see if we can come up with a pattern, or at least we'll have an idea. And when the actual result comes up, it shouldn't be a huge surprise. So now I'm basically adding 3 over 4 factorial, which is 1/8 to this. So it's kind of like 5 over 6, which comes from here, plus 1 over 8. The common denominator is 24. So let's go ahead and multiply by 4 here and 3 here. That's going to give us 5 times 4 plus 3, which is 23 over 24. That's kind of interesting. So what I'm seeing here is, so far, the denominator is always 1 less than the numerator. And if you're not convinced, and obviously this is not gonna be a proof by any means, but at least it should give you an idea. Okay, I'm not completely convinced, but I think there's a difference of 1. And you can do more and more on this. But that's what I'm thinking. Okay, what about the denominators? Look at the denominators. The denominators are also special in some sense, 2, 6, and 24. What does that remind you? Well, we're looking at factorials, aren't we? So are they factorials? And the answer is yes. So this is like 1 over 2 factorial. This is like 5 over 3 factorial. And this is like 23 over 4 factorial. Okay, great. But where does the 5 come from? Since 5 is 1 less than 6, we could also write it as follows. We can write this as 2 factorial minus 1 over 2 factorial. And we can write this as 3 factorial minus 1 over 3 factorial. And we can write this as 4 factorial minus 1 over 4 factorial. And in general, if this is true in general, then it should be something like n factorial minus 1 over n factorial. And obviously, this could be split up into 2 fractions, such as 1 minus 1 over n factorial. So that's my guess. Let's go ahead and see how this plays out. Okay, so we have this sum, 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial, and so on and so forth. There is no end. But to understand what happens if this happens to be an infinite sum, then we can actually stop at some point, like let's say start at the nth term. That would be n over n plus 1 factorial. And then look at this sum, this partial sum, as n approaches infinity. That's what our infinite sum means, right? In some sense. So let's go ahead and write this as a limit. So I'm going to put the limit here in the front, like this. Limit as n approaches infinity of this sum. Or of course, we also need to talk about the convergence, so on and so forth. But when you're able to find a closed formula for this sum, then obviously you can take the limit, and if that limit exists, then we can say it's convergent. Okay, so how do you interpret this? Well, this kind of tells me something about what I can do, because I kind of need to break it down. Notice that 1 is 1 less than the 2, and the 2 is 1 less, and 3 is 1 less than the 4, so on and so forth. The difference between n plus 1 and n is always 1. Great. So can I just write the numerator as 2 minus 1 over 2 factorial then? And this one as 3 minus 1 over 3 factorial, and then 4 minus 1 over 4 factorial, and all the way to the nth term, n plus 1 minus 1. Of course, I have to add 1 and subtract 1 to it because n is a variable, and then I can go ahead and write it like this. Okay, now we're going to take the limit as n approaches infinity, right? So let's go ahead and take a look at what kind of sum we get from here. Now 2 over 2 factorial is equal to what? Well, 2 factorial is 2 times 1 factorial, or just 1. We can basically write this as 1 over 1 factorial. And then this gives us 3 over 3 factorial, which is 3 over 3 times 2 factorial. The 3's cancel out. 1 over 2 factorial minus 1 over 3 factorial. And then now you probably got the pattern: 1 over 1 factorial minus 1 over 2 factorial plus 1 over 2 factorial minus 1 over 3 factorial, 1 over 3 factorial minus 1 over 4 factorial, and finally we get 1 over n factorial minus 1 over n plus 1 factorial. Okay, makes sense? Okay, let's move this a little bit to the left like this. Okay, so we can kind of fit it on the screen. Great. Now again, this is a limit, so let's go ahead and write it as a limit. So we're going to put the limit here as n approaches infinity. Now what we're going to do with this limit is a lot of things are going to cancel out. For example, 1 over 2 factorial is negative and positive. This is negative and positive, so on and so forth. Pretty much everything except for the last term and the first term are going to cancel out. So this is going to give us limit as n approaches infinity of 1 over 1 factorial can just be written as 1 minus 1 over n plus 1 factorial. Obviously, n plus 1 factorial is just going to grow much faster than n, right? So as n approaches infinity, 1 over n plus 1 factorial is going to approach 1 over infinity, which is 0. So this is going to approach 0, right? And our limit is going to be 1 as n approaches infinity. What is that supposed to mean? It means that this sum that we were talking about, 1 over 2 factorial plus 2 over 3 factorial plus 3 over 4 factorial, happens to equal 1 at infinity. It's just a limit, so you can kind of talk about this for a long time, but that's not the purpose. Anyways, so we were able to evaluate this infinite sum, and that happens to be 1. Why does it converge? Because this limit exists, therefore it is convergent. Let's go ahead and take a look at some results from Wolfram Alpha, and we're just going to finish up. So the input interpretation is like that. And then now what's interesting about this is that this is related to the gamma function, because remember the factorials can be written as gamma functions, and gamma function obviously generalizes this for real numbers. And then its sum is evaluated as 1, and that's definitely a convergent sum. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.